I'm Emma Kowal, Professor of Anthropology at the Therapeutic Institute for Citizenship and Globalisation, also convener of the Science and Society Network. And you can tell I'm a little bit viral, but by no means has dampened my enthusiasm and excitement for the conversations that we're going to have. So first of all, I of course acknowledge the Boonwurrung people of the Kulin Nations, the traditional owners of the land on which we gather today. And I pay my respects to the local people for allowing us to have our gathering on this land, and pay respects to their elders past, present and future. So these Alfred Deakin Institute policy forums aim to provide a high-profile platform by which the Institute brings together policymakers, researchers and community members for an informed debate on emerging policy issues. Previous topics have included the challenges facing Southern Sudanese and Horn of Africa youth in Melbourne, questioning punitive approaches in social policy, including the cashless welfare card in Indigenous communities, and homelessness in the 21st century Australian city. Tonight we have something completely different, how the environment gets under our skin. Epigenetics and microbiomics are hot topics in science and in the media. Please come in. Our first speaker, Jeff, will explain these terms more fully, I'm sure, but to put it very briefly, epigenetics is the regulation and expression of genes. That's epigenetics in a sentence. If we think of our genes as a musical score, a metaphor that's often cited in the media, epigenetic mechanisms are how that score is played. It's what it ends up sounding like. Our microbiome is the ecology of microbes, bacteria, fungi, protozoa and viruses that live on us and in us. These non-human creatures are critical to the function of our skin, lungs, digestion and everything else. So our environment affects these things intimately and profoundly. Everything from smoking, alcohol consumption, diet, physical activity, stress, trauma, infectious disease, pollutants, sun exposure, working night shift, or any other environmental factors you can think of have been shown to affect our epigenome, how our genes are expressed, and our microbiomes. In what anthropologist Margaret Locke once called the eclipse of the gene, 20th century ideas about the importance of genetics in health and disease and the triumph of nature over nurture have been overtaken by knowledge about these biological mechanisms that show how the environment gets under our skin and how our environments get under the skin of our children and our grandchildren. As we hear tonight about these developments and what they might mean, we will return to the question of we'll return again to the question of what these mean for policy, social policy, health policy, and environmental policy for a start. Do epigenomics and microbiomics merely provide a scientific label for the environmental and social determinants of health we've known about for decades and in fact centuries? Or are they showing us completely new associations and new effects? And whether epigenomic and microbiomic findings tell familiar or radically new stories about health and disease, what chance do they have to influence policy to maximise the health and well-being of the population, and to do this in an equitable way? So these are just some of the questions we will shed light on tonight. And we have four amazing speakers. Associate Professor Geoffrey Craig from the School of Medicine, Associate Professor Maurizio Maloney from the Alfred Deakin Institute, Dr. Evie Kendall from the School of Medicine, and Associate Professor Megan Munsey from Stem Cells Australia. And I'll introduce each of them as we go through. Each speaker will speak for around 10 minutes. And then we'll have plenty of time. We'll get the speakers to come up the front and we'll have some really good discussion. So, and that is me. So first up to speak is Jeff Craig, who is at Deakin University in Victoria. He studies the role of epigenetics in mediating the effects of early life. An early life environment on risk of chronic disease. He's established a number of longitudinal cohorts, most involving twins. He's a chief investigator on the NHMRC-funded Twin Centre of Research Excellence and president of the International Society for Twin Studies. In the broader context, he's interested in the interactions between human and environmental health. And I will pass over to Jeff to tell us about the mechanisms behind the early life origins of disease.
Thanks, Emma. It's great to be here, and this is, to me, the start of the beginning of a wonderfully interesting journey that could have only happened at Deakin University. So, the first question I'll pose is, what actually makes us us? Well, we're a mixture of our genes, our fixed genetic code, our environment that we were exposed to from the womb to the tomb, as it were, but also chance. A lot of what we are from the development through to old aging is by chance. So we must always think that we are a product of all these. And that gets around the idea of determinism. We are not just a product of our genes. We're not just a product of our environment. There is a lot of chance in our lives. So it's about knowing that influences our desire to know about health. I and many others like me focus on the reasons why people develop chronic diseases. Now, chronic diseases, they're everything from diabetes to cancer, cardiovascular disease, Alzheimer's, Parkinson's, but also chronic diseases that originate in early life, such as asthma, autism, and schizophrenia. They are chronic ongoing disorders. A meta-analysis, a study of studies of twin studies of over 1 million twins, showed that genes account for genetic variation within a population, accounts for quite a lot less than environmental contributions to these disorders. The total number of chronic disorders, people who die from chronic disorders that are preventable, the preventable proportion, which is about a third, 13 million deaths per year annually. So wouldn't it be great to try to start cracking that? The next question is, when is environment important? We know we're all urged to, that as a man I'm told that, we're not allowed to, watch our waistline and, watch our belt hooks and try to eat more healthily. But really, when is the best time that we can optimize our future health? Well, we got a clue of this about 20 years ago. Some Dutch researchers looked at the offspring of those mothers who were pregnant at the time of the Dutch famine when the Nazis annexed part of the Netherlands at the end of the Second World War. And they compared the health of these 60-year-olds to their brothers and sisters that were not in the womb at the same time, and they had an elevated risk for all chronic diseases, from heart disease to Alzheimer's. So something about that famine left a long-lasting legacy in these individuals, something that literally got under the skin of their mothers, got passed through to the next generation. What is that? Well, we'll come back later. Something is happening. And so this gave birth to the field of the early life origins of chronic disease. Some of you may have heard of the Barker hypothesis, or the developmental origins of chronic disease. It basically says that chronic diseases, some people say they originate in the first 1,000 days, from conception through to age 2. In reality, areas like adolescent health has been neglected, and people like George Patton and Susan Sawyer in Melbourne are showing that you can engage with adolescents and understand how their exposures, their experience can influence future risk, but also the risk of a disease in their offspring. It's a fascinating area. And really what the aim of this area is to focus on this graph, which basically along the bottom we see life course, and along the side we see chronic disease risk. We have the smaller genetic contribution to risk at the start, then we get accumulation of environment and chance. And what happens is, as an adult, yes, we can change our behaviours, we can change society to help reduce the risk. And the earlier we intervene, the idea goes, that the greater that we reduce the lifetime risk. So intervention and recognition in mothers and infants will provide the greatest benefit for risk. There's also the idea that I've touched on at the moment that environments in one generation can influence the health of the next. This is a thing. It's been proven in animal studies this happens, that what happens in one generation can be passed on to the next. And there's a whole lot of information in studies of human populations that this is the case. It's just been a race to try to pinpoint the specific factors and to study individuals long enough for 2 or 3 generations. A prime example that we know is very simple to understand. If it's a pregnant woman smokes, those chemicals in the smoke go into her, they pass into the unborn baby, and if the baby's a female, they affect the germ cells, the cells that go to form the eggs, in fact, to produce the individual, the granddaughter of that mother. So it's a direct transmission or an effect of an environment on a pregnant mother. But we also know that the environment that men encounter can be passed to future generations, and that's been shown unequivocally in some animal studies. There's still debate whether it can happen in humans. But I like the idea that we can pass it on or pay it forward. What we do in this generation beneficially can be passed down to the next generations. It can be as simple as an elder in the community or a grandparent assisting with the child rearing, for example, and ensuring that mothers and young children are well protected. Onto the mechanisms, and this is what I study, the mechanisms of the early life origins of disease. And this idea of epigenetics, and Emma introduced it early on. Epigenetics is chemical modifications or chemical tweaks to DNA molecules that change the genetic activity. I liken epigenetics to the musicians that play the symphony of life on our genes. The genes are like the instruments, they can't play themselves. For the full symphony, you need the musicians playing the genes. You need the small molecules and the DNA. 3 people have been, at least 3 people have been talking about what epigenetics is for 2,000 years. It's not a new idea. Aristotle coined the term epigenesis. He said that instead of a homunculus that grows big, we start simple, a zygote, and then develop into complex human beings with the same DNA doing lots of different things throughout the body. Conrad Waddington in 1942 described epigenetics as the interactions of genes with the environment as we develop. So that he extended that idea of development. So he talked about gene-environment interactions. And then Art Riggs in 1996 talked about changes in gene activity passed on when a cell divides. I think of it as like an alarm clock. When a cell divides, it goes to sleep. It needs to be reminded what it is. A heart cell or a liver cell or an eye cell are nothing different. And the key words here are epigenetics is involved in development. It is changed by the environment, but what that means is that our genome is, and our organisms are plastic. They can be changed. They can be changed during development, but they can also be changed during environment. Very different concepts to genetics that are fixed. We can be changed. The question is how. And the idea about being passed on from when a cell divides, the other idea discussed is can it be passed on when from one generation to the other. And some definitions of epigenetics do include that definition. Epigenetics has been studied in many disorders, but for the longest time in cancer. Cancer is a genetic and an epigenetic disorder. We need to look at both. Currently, epigenetic tests are in the clinic for cancer. They're also using information about epigenetic state in cancer to design therapies, and also biomarkers to predict response to therapies. So epigenetic tests are a reality in cancer. They're in clinical trials, they're in the clinic. Another condition that I'd like to talk about is an epigenetic condition. or it's a combination of epigenetic and genetic. Prader Willi syndrome. And individuals like Chloe with Prader Willi syndrome the main part of the diagnosis is hyperphagia. They have an overwhelming desire to eat and eat too much. They are often floppy babies. They also have a lot of anxiety and get sick a lot. And unfortunately, at the moment, Chloe is very sick. And I'm a board member of Prader Willi Research Foundation Australia, and we are aiming to fund studies that reactivate these children's genes. Now, what do I mean? I mean that normal individuals have 2 copies from mum and dad, like all of us, of every chromosome. They have imprinted genes. Imprinted genes mean that one parent's gene copies are off, as in red, and the other parents are on, as in green. What happens in Prader Willi is that the copy that's on from dad is deleted or turned off somehow, so all you have is off genes. If we can actually reactivate those off genes, turn them on, and now there's epigenetic, you can target epigenetic drugs to activate specific genes. Our aim is to reactivate these genes, but it's not that easy. If it's something that's happening in the brain of these children, how can we do that? We need basic research to start kicking that off. Back to chronic diseases. A group of Dutch scientists about 10 years ago in a landmark study looked at these 60-year-olds and their brothers and sisters and found that their epigenetics was different, at a key gene involved in prenatal growth. So they showed that 60 years later, the epigenetics difference was still there. So the idea is it's fixed early on by that environment and inherited from cell generation to cell generation. But still, we don't know whether that could have been changed or not. My work, and many others, focuses around the idea, for example, of looking at measuring epigenetic state in newborns and young children, asking which prenatal exposures, such as smoking, drinking, affected those, but more importantly, using that idea of the early life origins of disease, ask whether the future of these individuals is written in their epigenetics. At the moment, there's a lot of emerging evidence. I've published individual studies, and others have, but there's no current test. That's the state of the art at the moment. What there is a test for at the moment, is the idea that what people have looked at is are there any genes whose epigenetic state is associated with aging? And yes, the answer is yes. And this hasn't got to a diagnostic test. However, there's a direct-to-consumer test called MyDNH. So again, it's based on good science, but how responsible is it to bring out a test like this? Lastly, on to microbiomes. And I will have a short video, which should go like this, 2 minutes.
Microbiomes are collections of microorganisms that live together in a given environment. Every soil and sediment on Earth has a microbiome. There are microbiomes in the ocean and even in the atmosphere. In your body, there are microbiomes in your skin, in your mouth, your digestive tract, anywhere the body comes into contact with the outside world. All life on Earth evolved together, so microbes need us and we need them. We depend on microorganisms to help us break down nutrients and produce important vitamins and enzymes in our digestive system. It's estimated that there are over 1,000 different kinds of microorganisms living inside our bodies, containing about 300 times more genes than our own human cells. If you put together all the microorganisms inside you into one mass, it would weigh as much as 6 pounds. In comparison, your brain only weighs about 3 pounds. Each of us carries inside of us a unique fingerprint of microbial diversity. Your unique microbiome starts as soon as you're born and is influenced by your diet, your experiences, what you're exposed to, and where you live. In some cases, your microbiomes can even affect your mood and behavior. Scientists believe there are several pathways through which the bacteria and other microbes in your body influence your brain chemistry. For example, experiments have shown that organisms that are raised in a completely sterile environment perform differently in tasks related to learning, memory, and social behavior. Currently, scientists don't have a perfect understanding of how these microbiomes work. Although we can catalog with incredible precision and speed the number of microbes living inside of us and around us, we still have a large gap in knowing how these communities interact with each other and with their environments. To develop the kinds of tools needed to study microbial communities and how they function, we need a unified approach that draws on many different disciplines. From the inside of a single cell up to the size of our entire planet, we need new technologies and methods to help us decipher the working principles of these communities. If we can understand these complex systems, it would have a large impact on how we interact with the natural world. There are applications in agriculture and crop productivity, in climate science and carbon cycling, in sustainable energy and biofuels, and in health and medicine to treat disease or create new therapies. Understanding microbiomes may even one day help us to colonize.
Skip that last bit about exploring the moon. So, where is microbiome research? Well, at the moment, it's certainly where the biggest breakthrough is to treat conditions like this Clostridium difficile diarrhea. So, poop transplants or fecal transplants from healthy people have been used to cure people of this disorder. There's been some interesting results also with inflammatory bowel disease. But beyond that, there's not a lot that's a proven medical intervention. Even probiotics that you find at the chemist, those mixture of microbiota that are supposed to be good for you, it's still confusing that the evidence isn't in that they are that beneficial. And so it's again, like epigenetics, it's a nascent science where there's very small number of tests, but there's a lot more to be done. Slowly, as I said, slowly accumulating promising evidence with likely future benefits. But we need to proceed with caution. We need to know what's the truth out there, what are the tests based on strong scientific knowledge. But in the meantime, I think we can focus on the effect of known effect of environment. We know generally what's good for us. We know nutrition, and we know, for example, it's great to include these fermented foods in your diet, and thought that stimulates the microbiome. And there's certain things that we can avoid. Now, I said that on purpose. There's obviously some things that we cannot avoid. We can't avoid war. We can't avoid pollution, unless we go out and live in the countryside somewhere. And there's a lot of these. So it's a big question of choice or policy, and that's where I'll end. That we need to think more. Many people talk about it's our choice, and for many people don't have a choice. So how do we best move forward with these new technologies to be equitable for everyone? So thanks, everyone.
Thank you, Jeff. So next we have Maurizio Maloney, a social theorist with strong affiliations in the history of science. He's the author of Political Biology, co-editor of Biosocial Matters, and chief editor of the Palgrave Handbook of Biology and Society. And his upcoming book, coming out next year, is Impressionable Biologies, from the Archaeology of Plasticity to the Sociology of Epigenetics. He is Associate Professor of Sociology at the Alfred Deakin Institute, and he's going to talk to us about the social implications of epigenetics.
Thank you very much, Emma. So I think I decided to give a sort of more historical talk. I keep believing that history is important and will help us frame contemporary policy debates in a sort of more cautious and aware understanding of what happened. So I would like to make a few claims in my talk, but the problem is that with these glasses I can't see there. I can't see there either, so I need to take another. There is not a pointer for... No, don't worry. I can do this. So, okay, a few claims I want to make in my talk. So one is that, obviously, the point here for me is not so much how the environment gets under the skin, but how the Western imagination at some point in the history of the modern biomedical body has forgotten this obvious truth that we are our environment, and how this magnificent technology that is the modern biomedical body has withdrawn itself from environmental forces and constructed a self-bounded, regulated kind of organism. But so the first obvious point is that we should not be dazzled by the apparent novelty of today's views of the body as deeply shaped by environmental forces. The second point is that, of course, the molecular mechanisms of plasticity are new, but the ethical problem of how to live with a permeable body, a body continuously exposed to environmental changes, is very old and very pervasive in traditions of medicine predating and coexisting with Western biomedicine. And the third important point for me is that this knowledge of a body plastic to environmental forces has rarely been innocent or disconnected from wider political considerations. So histories of corporeal plasticity have always been highly gendered, as I will show, racialized and classed, and they have mostly mapped and reproduced hierarchies through physiological distinctions. Okay, so this is an obvious starting point, which is humoralism and ancient medicine, which is mostly a theory of an open and unfinished body. So this is a very nice quote, I think. Old Greek medical theory is a theory of poroi, a theory of the infinitely penetrable body. So poroi is from where the English word pores come from. So it's literally the passage, the pathway, the channels. And all ancient and early modern, just to stay within the Western tradition, view of the body is this dilemma of a body that is continuously open to environmental forces, so that it has to use environmental forces like food or sleep or rest or waters to make itself better. But at the same time, there is potentially a relation of antagonism with these forces, because these forces can be dangerous. It can shape the body in a way that is not good. So here there are a few images, and this is important. It's not only the body, but it's the body-mind. So notions of melancholy as shaped by the passage of Saturn were, very, very influential in ancient medicine, in the Middle Age, and the classical, obviously, a reference point of this environmental view of the bodies, Hippocrates on earth, waters and places. So this is a very nice citation from Gilles Deleuze. At that time, bodies were made of contracted water, earth, light, and air. Now, but as I was saying, this is what really is my, I think, contribution to the field, because I'm not a historian or pure historian. I think the point is, where is the boundary between this knowledge and its politics? So, here there are a few obvious examples that this knowledge that the environment shapes people profoundly and people mirror the environment in which they live is not only a knowledge of an ontology of people, but it becomes immediately turned into a way to make hierarchies between social groups, to make biopolitical categories between groups. So this is a classical. This is, in a sense, the beginning of what Edward Said would call Orientalism. So this is the classical distinction between Greeks and later Romans and Asians. So the difference, both Hippocrates and Aristotle would say that Asians live in this uniform climate, which shows no violent changes either towards heat, or towards cold. And because of this uniformity of the climate, they are softer, more delicate, and warlike. So this is a nice version of Hippocrates. Aristotle is a bit more malicious, say yes. So this is why they are prone to slavery. This is why they will not rebel against the tyrant. So notions of natural slavery, the seventh book of Aristotle Politics, are based exactly on this environmentalist trope of Oriental lack of manly courage. And you find in this ancient military literature, so this is an important point for me, the debate is not about the philosophy of plasticity. These are biopolitical techniques of plasticity where the notion of plasticity was collaborated. So you have these ancient military treatises for instance, in the Roman army, where there is a clear suggestion to avoid recruiting troops from certain areas because their blood is not, or is too much, or is not good enough, etc. And even the most famous, probably, biopolitical claim of all ancient times, it reflects this power, plastic power of environment shaping people, which is the notion that soft lands breed soft men. So this is to say that this sort of framework for understanding the relationship between people and milieu was very pervasive. This is interesting, I think. So one of the key points is that this west-east axis of plasticity suddenly changes with early modernity and becomes a north-south axis, in which the difference is no longer between the laziness or unwarlike temperament of the Asians, but is about people in the tropics. And here there is all the literature about this Aristotelian framework of geography has been reframed into a north-south axis, and the kind of geography, for instance, Columbus used to make argument about people in the Indies not able to govern themselves, which reflect exactly Aristotle's point about natural slavery. This is a more subtle problem for that kind of porous body of ancient and early modern times. So what happens to a body where there is not a clear notion of the skin, where there is not a clear notion of heredity, when this body emigrates in a completely different landscape? If we are contracted water, earth, air, and light, what happens if we change radically our scene, as in the case of Spanish colonizers when they went to the Americas? So all the concern about are we going to degenerate and become like the Indians? How can we maintain our biological difference? So there is all the micropolitics of importing food and wine from Spain, to use food as a sort of micropolitics of race to keep the boundary well separated between the colonizers and the colonized. But at the same time, obviously, progressive authors like Bartolomé de las Casas made the other point and said, well, if we are all changeable, why don't we try to change them for the better native people through the right food and the right environment? So, and yes, this special porosity of certain areas or groups has always been very prominent in medical theory. So this is, for instance, from a mid-18th century French medical treatise. Children, women, people who live in rainy climates or in proximity to rivers and swamps, who live a sedentary, lazy life, feed themselves on fatty, watery food, where a cold and humid temperament have naturally soft or relaxed fibers. This notion of special softness of certain groups, gender, or classes is very important. Now, it's not only the physical environment that gets under the skin in traditional literature in early ancient and early modern times. So this is one example I cannot go to, but if you look at saints in the Middle Age, what gets under the skin is God itself. So this is one of the most famous cases of impressionable body in the Middle Age, Santa Chiara from Montefalco in Umbria in Italy, and this is her heart, which reflects the cross of Jesus, and this is her bladder, where there are 3 stones that would reflect the Trinity. So this idea that her body was totally porous to the mystical experience was very important. But the very visible phenomenon is not so much saints and mystics, but is the so-called maternal impression. So the idea that the thoughts, emotion, experiences of a pregnant woman could imprint on the physiology of her unborn child. So I want you to reflect that we have here with mothers and fetuses that have been pretty prominent also in the previous presentation. We have a sort of double layer of vulnerability and plasticity. So mothers are particularly mobile and softer and open to imagination and environmental influences of many sort. And the fetus is also a second layer of particular penetrability for the forces of the environment. At the same time, is a notion, as I will say, talking about how geneticists attacked this idea of maternal impression, that obviously keep a certain power in mothers to shape hereditary trajectories in the future. So stories of maternal imprints, I think it's a notion that you have heard. For me, growing up in Italy, it was still at my time important. My mother shouldn't see someone doing something very dangerous or wrong, because this could have created, we call it voglie, so they are like stain on the skin of the fetus. So this literature was, very popular in Italy until in the 1970s. It was famous that in the 19th century, pregnant mothers went to concerts or to listen to writers in order to have the idea to shape the biology of their fetus. So, but these stories of maternal imprint are mostly terrifying stories, and often they are racialized, as I will show. It's late. I have to stop?
Well,
I think I'm stopping. There is an end, yes. So this is the famous case of Hippocrates that, this white royal couple conceive a child black as a Moor, and the princess is accused of adultery, but Hippocrates saves her by pointing out the imaginative effect of a portrait of a Moor that was hung over her bed. And that was even used in the legal literature in the Renaissance. But anyway, so I don't have time to go ahead, I think, right? Well, the argument I wanted just to make is that we can see nowadays sort of resurfacing of some of these topics, but it's probably something we shall discuss in the Q&A because I don't want to occupy more time. All right, thank you.
Okay, thank you. I'd love to keep going, but we don't have unlimited time, unfortunately. And I wanted to, but maybe we can come back to some of these issues. So next is Evie Kendall, who is an emerging technology ethicist. She's both emerging and emphasising emerging technologies with a particular interest in reproductive technologies. She's a lecturer of bioethics and health humanities with the ethics, law and professionalism team at the Deakin University School of Medicine, and she is heading up the ethical, legal and social implications of emerging technologies, LCET research group, which is supported by the Science and Society Network. Thanks, Evie.
Okay. So, fantastic talks thus far. So we've heard Jeff talk about the potential for some of these emerging technologies to help us avoiding chronic diseases, and of course one of our goals is to be able to test genetics and epigenetics such that we can avoid diseases, hopefully prenatally, so we can actually have a really big impact. And of course we've heard from Maurizio some of the risks of actually allowing ourselves to treat human life in a different way. So things like genetic determinism, the idea that we are our genes, we have some risks sociologically connected to that. So I'm actually going to be talking about ethical issues in emerging genetic technologies with a particular focus on prenatal testing and gene editing. So these are things that have the potential to really change how we view humanity. So we have some wonderful words that we like to use in bioethics, and one of them is commodification. So you'll hear the term designer baby as this horrible thing that we want to avoid. We don't want to engage in gene editing because we're going to create designer babies, and that will somehow hurt our parent-child relationships. So first up, I've got up there commodification of children, because this is something we talk about in terms of things that should not be on sale. So babies are not something that we should traffic, babies are not something that we should sell. So when we talk about gene editing or gene testing with the intention of creating particular types of offspring or selecting the kind of offspring that we want, sometimes there's a concern that we are treating children as if they are tradable objects, things that we can buy. So you can choose what flavour smoothie you want, you can now choose what kind of baby you want, and that's one of our ethical concerns. So a lot of people will counter that argument by saying we're not trading in children, we're engaging in prevention of disease, and of course that is our goal through most of these emerging techs. We are trying to improve quality of life for people in society. However, we do also have some legal cases where things like genetic tests that have come back falsely normal have then led to things like wrongful birth suits. So gene testing labs have been sued because parents felt like they didn't have the freedom to terminate pregnancies that they would otherwise have chosen to terminate had they known there'd been some sort of genetic defect. So of course you're thinking, okay, commodification of children, perhaps that's not really what's happening here, but when these parents have paid for genetic tests and they have not got the results that they were after, they have sued for financial compensation as a result. So perhaps there is a bit of a trade going on there. Now we're concerned about that because parent-child relationships, we have an idea in society that these should be unconditionally loving relationships. So they shouldn't be contingent on things like genetic traits that the child might have. We might have a romanticised view that we want the child to have our eye colour or our hair colour or something like that, but that shouldn't be the reason we either love or do not love our offspring. Of course, we've got some fantastic literature coming out. Anna Smajdal has written some fantastic literature about the conditionally wanted pregnancy. So we're now in a situation where talking about intended or unintended pregnancies, wanted or unwanted pregnancies are no longer valid. We have most people experiencing conditionally wanted pregnancies, with the condition being that the fetus they're growing is genetically normal. And a lot of the prenatal tests that we're talking about are actually focused on whether or not we think this fetus is going to be typical. And then, of course, a pregnancy might be wanted if the result is what they want, and become unwanted if it isn't. So this is actually quite a challenging space that pregnant women are living in right now. We have an issue with genetic testing, and particularly with potential gene editing of humans, where we will draw the line between treating something or avoiding a disease and actually enhancing certain traits that we want, or perhaps we can make our child taller, so not just healthier in terms of avoiding these defects that we've listed, but also having some beneficial trait that we want to bring in. This immediately leads to concerns about discrimination against people with disabilities. Of course, whenever we say that something is a disability or a disease, that might carry some stigma for people living with those conditions, who may or may not see themselves as having a disability. This also leads to the accusations of eugenics, so the idea that we can improve humanity by manipulating our genes. So we'll all be 10 foot tall, we'll all have blonde hair, blue eyes, etc. So of course we know the historical examples there, so I won't go into that. But these are concerns that we do have ethically with emerging genetic technologies. What is it going to do about how we think about humanity, and what kind of shared experience we think we have? Loss of genetic diversity by choosing to exclude certain traits that have been characterised as abnormal or atypical, whichever language you want to use there, does also have some concerns. We are ethically concerned with how that will translate to the treatment of people in society that are different already. Remembering that the vast majority of disabilities are actually acquired, they are not inherited. So when we start thinking about genes as what you are, we do have some concerns regarding the treatment of people with disabilities. So that's just some general ideas to start with. So we're concerned about designer babies and rejecting the idea of the given. So some people will have some traits, other people will have other traits, and that's just part of what makes us the diverse group of people we call humanity. Now, the overhyping of genetic and epigenetic editing using things like CRISPR-Cas9 has a lot of ethical problems as well. So this is partly to do with people misunderstanding what we're actually capable of doing with this technology. So CRISPR-Cas9 is exploiting a naturally evolved protective behaviour of single-celled organisms. So part of prokaryotic immune responses are actually the ability to splice out foreign invading genetic material from viruses, for example. So exploiting that particular technique, we could theoretically be splicing things in and out of the human genome, and we can be engaging in epigenetic editing as well. So concerns there are, of course, what if someone decided they wanted to glow in the dark? Are we actually going to splice those fluorescent genes into them? I don't think we are, but there are concerns about that. Then, of course, we have the issue of if we have this wonderful array of genetic tests available and all this fantastic gene editing that avoids diseases for those that can afford it, does that mean we only have these genetic conditions arising in families that are of lower socioeconomic status? And what is that going to do in terms of social support for those groups? Will these parents be blamed for not engaging in gene editing to avoid certain conditions that we have socially classified as disabilities or diseases? Data privacy, you hear a lot about big data, your privacy. The information in your genes is of course information that talks about you but also your family. So you may be willing to consent to certain tests and having certain data available, but your family may not be aware of that or they may not consent to it. So how we're going to deal with genetic technologies moving forward, the kind of tests that we can do, is really going to have to deal with the relational element of a family-owned data set and how we're going to consent to the collection and use of that data. I'm not really going to talk about exploitative advertising because I know we're a little short of time and I know Megan's actually going to be talking about that quite a lot, but we are concerned about the exploitation of vulnerable people, particularly if we have this overhyping of possibilities, people believing that we can solve all problems through genetic testing, that we can alter our children to be exactly what we would buy in the supermarket. Of course, this is going to be scientifically inaccurate, but it has a lot of ethical sort of ramifications as well. All in all, we're looking at something that really does have the potential to alter how we feel about our children in particular, and obviously adults are going through these tests as well. So just tying into Maurizio's point, of course, looking at the experience of pregnant women over time and how the environment was impacting their fetuses and how we actually treated them socially. We have a few great studies, including one by Barbara Duden, who looked at how pregnancy was actually perceived through time. Historically, you were pregnant when you experienced quickening, so when the baby kicked, that was when you were pregnant. Up until that point, you possibly had a tumour, and there was no way to know. Now you're pregnant when you get your blood test and it tells you you're pregnant, but you're not really pregnant until you have your sonogram picture, and then you might have a healthy pregnancy, and the language starts to change. And of course, one big difference we have there is the quickening is something only the pregnant woman herself experiences. So that is something that we have to trust that woman. She's pregnant. She's told us she's pregnant. She felt it. Now she's only pregnant if she's been scanned and tested and we've medically decided that she's pregnant. It's a very different starting point. With all these gene technologies, maybe she's only going to be pregnant when we've seen the full genome already typed out and we found out that this is an acceptable human genome and we're going to allow that particular child to be born. So our language changes yet again. So we won't have quite so much of the religious ramifications coming in about the image of the fetus, but we do have a fantastic story that I will leave you with, which was the Xerox defense that we poor women can't use anymore, which was that if you were extremely devout, it made sense that your fetus and then your baby would look suspiciously like the local priest when your husband and the men were all out there fighting in wars. The Xerox defense was fantastic because the women would be staying home. Of course, the priest stayed home as well. He didn't go to war. And then all the babies coming out in the next generation looked suspiciously like the priest. But if you were very devout and you had looked so lovingly toward that symbol of religious piety, it made sense that that was the environment imprinting on your child. And that was something that women did use as a defense against supposed infidelity. So, again, what is our genes going to tell us about who's a real parent, who's a real child? What do we actually think is valid in terms of perpetuating the human species? I'll leave you with that. Thank you.
Thank you, Evie. Amazing. So our last talk is from Megan Munsey, who's Deputy Director of the University of Melbourne's Centre for Stem Cell Systems within the School of Biomedical Sciences, and she also heads the Ethics, Engagement and Policy Unit of the Australian Government-funded Stem Cells Australia Initiative, so she is busy. She's always been fascinated by technology and its impact on society. In addition to her 20-year career in stem cell science, she worked for over 10 years as an embryologist in Australian IVF clinics. So thank you, Megan.
So I think my slides are over here.
You just click through, I put them in.
Oh, you put them in. Oh, great. Thank you. Excellent. So, thank you very much for the invitation to come and speak and be part of this interesting discussion, and thanks Eve for setting it up so well for me, because I wanted to take it kind of a sidestep and to talk a little bit about another emerging technology, and perhaps to reflect on how we can do it better as we go forward. As Emma mentioned, I've been working in the stem cell field for over 20 years, and I think there's some things we've done very well, but I think there's been some concerning practices that I can see playing out yet again unless we're careful. So I think we need to think very hard about how to engage with the community, how to avoid overhype, and how to question, well, what policies to put in place really to frame this technology as it comes. So what I'm going to do is just spend 5 minutes or so just reflecting on what we've seen in the stem cell space, some of the concerning practices, and some of the challenges that we've faced as we've tried to address them. So headlines like these, and I think we've seen quite a few other examples in Jeff's presentation that perhaps capture this new technology. But in the stem cell space, in particular, I think there's been a lot of hope invested. And I was looking at that quote in the middle there, cells of division, cells of hope. This idea that stem cells can somehow cure the incurable, a new way of addressing those chronic conditions. All of the conditions that Jeff mentioned are really claimed to be able to be helped by stem cells. And cells of divisions are also important because if you think about the stem cell debate 20 years ago, the debate was about embryonic stem cells derived from an embryo versus stem cells derived from an adult. The good versus the bad, or the ethical versus the unethical. And I think this idea of division was terribly unhelpful. As a practitioner, what it meant for me, as someone who had been working with embryos, who had seen that there were many people facing a dilemma at the end of their infertility treatment about what to do with excess embryos. You know, should they donate them to another couple? A snowflake baby? That was a possibility. But often they were really didn't find that very comfortable because a child that arose from that would be a full genetic match to their children. They were really having to throw the embryos out, and they found that difficult. So the idea of being able to possibly donate to a research project was attractive for some patients. So when the opportunity arose to be involved in a research project around making embryonic stem cells from embryos, I thought it was a really great idea. But what I wasn't expecting was this divide. And we had to argue for legislation in Australia to use embryos in research for stem cells. And I think in doing so, we overstated and overhyped. So hype is a really important aspect. It's driven by media, it's also driven by us. And I think we have to be careful of language and of terminology we use. And I think we have to be responsive when perhaps the debate is going a little bit off, but we need to be active. And I think certainly some of the technologists that I've worked with, we're quite cautious in getting involved in public discourse, and I think that's a big mistake. So lots of hype, lots of hope, lots of promise, and I think some legitimate promise. I don't think stem cells are a cure-all for everything, but there are tailored applications that are being investigated in clinical trials under appropriate conditions. We're learning, we're improving, and I hope one day we'll have some treatments. Of course, stem cells are already used if we're talking about specifically blood diseases, disease of blood and immune system, using stem cells from that system. But other applications are still very much in the development phase. However, people who've read headlines like that, or have a loved one who's suffering from a condition and read a headline like that, they'll hop online and perhaps they have a child or a grandchild who's been diagnosed with autism. And they feel as though there must be something there. There must be something out there for their child. So perhaps it'll be a fecal transplant could be offered, but I do see so many ads, so many concerning ads for stem cells. And this clinic that's offering stem cell treatments for autism may also be offering treatments for children with cerebral palsy or even adults with Parkinson's disease. Sometimes the same magical stem cell treatments. But I thought this was quite concerning, particularly the bottom one, 15 years of experience, over 22,000 patients treated, accredited, safe, proven treatment. Why wouldn't you go there? And of course that is bollocks, complete bollocks, But I think for people who are vulnerable, who are wanting to explore their options, this is really powerful. So as a scientist, and as part of an international consortium who are concerned about these practices, we first became aware of them around 2005. Interesting, like this clinic claims to have been treating. This clinic's based in Mexico, or this actually, the bottom one I think is based in Asia. Top one's in Mexico. We first became aware of these practices over 10 years ago. And as an international community, so we've got together and said, we're concerned about this. We need to have standards, we need to have demarcation. What's happening outside this kind of area, we should be concerned. However, the industry has continued to grow. It's fueled by, I think, people who are exploiting this hope. To be very clear, these are procedures being offered outside clinical trials. They don't have an evidence basis that we would recognise, perhaps the patients do. But what we've always been concerned about is risk to patients, not just risk to health, but psychological risk, going down a pathway, a deviation from conventional care that may be very disappointing, but also financial risk. These are expensive treatments. It may be $30,000 plus airfare, plus weeks at a clinic in Mexico for this family. The community might come together and rally around them to provide that funding, and yet when they come back, they have to say, well, I think it's helped. I'm really glad that they had a try. So it's a really challenging area, and one of the things that I wanted to share was, and Claire Tanner's here with me, and we've been doing a lot of work in this area for many years. But what I thought was really interesting is one of the people we interviewed very early on in our study, a woman who'd taken her child with cerebral palsy to a clinic in Germany. She said that what's the worst that could happen? What's the worst that could happen? I could effectively do my money and get no result. And I think this issue the cost of the failure, cost of failing to act to address this issue are quite significant. And I just want to share a quick story, a case study that was published last year. So when 3 women in America went to a clinic in Florida, the clinic was the blah blah blindness clinic in Florida, and they were claiming to have treatments. In fact, they actually posted that they were doing a clinical trial. One of the women thought she was participating in a clinical trial. It's true, all women had macular degeneration. They still had enough vision that they could drive, but they wanted to try this new stem cell treatment. And it's true that there are some early phase clinical trials using stem cells or using cells derived from stem cells. Quite a different strategy that this clinic was operating on. But nonetheless, it's true that this clinical trial is being conducted in another clinic in the US, and it has had highly publicised early results that are encouraging. But these women thought, right, I want to have a go. The woman who thought she was participating in a clinical trial and then asked to pay to participate in a clinical trial thought that was worthy. She wanted to do something for the community. They had fat taken out of their abdomen, zhushed up and put back into their eyes, both eyes, same day procedure, rendered blind, can no longer drive. And I just think it illustrates that kind of the murkiness of which these practices exploit hope, and the challenge around regulating this. So I'll just step now to policy and say that, being part of this international committee, we wanted to have impact on policy. We want to see policy reform. So we all sort of set up these standards, these demarcations of what's acceptable, what's not, and then we went to talk to regulators. And so we kind of broke away and had these conversations at a jurisdictional level. And of course, I was very much involved in the Australian context. And in Australia, we've had a particular challenge over the last 8 years around using the patient's own cells. Autologous therapies are being promoted again outside clinical trials. No evidence, but effectively just marketed to patients. And as a researcher, as a scientist, I was quite naive. I just thought simply it's a matter of tweaking the policy a little bit, adding a few words to an existing exclusion that would force one of the regulators, in our case the Therapeutic Goods Administration, to have a greater role. Now, it's taken 8 years, a death of a woman, and we've only just had a reform introduced that will come into play next year. And I find that quite extraordinary. So policy response is slow. And I think we have to be galvanised and active, and we have to drive the reform. I think we have to be sympathetic that the policy makers work in very difficult circumstances. This area actually sits between medical practice and regulation of manufactured product. Unfortunately, after 8 years of arguing for change, I've got change, but I've got change around the regulation of a product. The services, I think, will still be exploited. So that conversation still hasn't ended. But I think we have a willingness to keep an active brief, and I think we've raised the level of awareness of risk, and that risk is beyond physical harm. But there's also the issue of contested space. And I just want to share this banner with you. This was hung in Italy when the Italian government took a stance against a foundation, a charity called the Stamina Foundation. And I don't know if you know this group. Yeah. So one of my colleagues, or a couple of my colleagues in Italy, stem cell scientists, were heavily involved in opposing this group. This group, I believe the head of it was a motivational speaker and a psychologist. And he saw the value in stem cells. They were taking cells from the bone marrow, and they also think from fat, claiming to convert them into nerves, and then using those cells to help dying and sick children. Charging for the privilege. There was no scientific foundation for it. My colleagues were asked to evaluate and came up with that expert report. There were many, many interactions around how to reform and close down this practice. When it eventually was closed down, there was mass outcry. So there's huge community backlash, not only from the parents and the children and a bare-breasted protester, which I've never seen before at a scientific rally or policy rally, but it's pretty graphic. It's in Nature. It's really kind of cool. But what was also interesting is that they had also co-opted or brought in a lot of celebrities. So it was this huge backlash. So scientific, non-evidence-based practice being kind of this practice being challenged by the mechanism you would usually think, but this huge community backlash about being denied. So I just think this idea of destroying hopes is worth sharing and worth thinking. And of course we want to try to avoid that extreme clash and contested space. So I'll leave it there, but thank you very much.
Okay, can I ask the speakers to come up to the front? And grab yourself some water. So have a seat. So we've had an amazing array of discussion. We've started off with thinking about how the environment and the body are completely integrated and entangled with each other, and how this has a very long history. And actually, our idea that we're kind of autonomous individuals separate from our environment was just a little bit of a late 19th century, 20th century fad, which is now over. And then we had a bit of, realism, pessimism, thinking about what are the bioethical, what are the risks that we're running, and then what are the risks in terms of the market that is always waiting to step in with some pretty dodgy things that people can get very, very attached to. I want to open it. I've got some questions, but I want to open up first. Yes, John.
Thank you for your wonderful talks. Really, really great. I'm John Gartner. I'm a sociologist at Monash University. So I wanted to start by making a potentially controversial statement. So you'll know the Medical Research Future Fund, which I think is supposed to be about 20 billion Australian dollars. That's a lot of money, and I think some of that money may come from cuts to the healthcare service. So my thoughts are, and I'm going to play devil's advocate here, that is a waste of money, and that money should go directly to funding social interventions to improve people's environment, right? So if we follow this epigenetic logic, why then are we targeting the genome with high cost, difficult to develop therapies when we could improve a lot more lives by targeting the environment instead? So I wonder if anyone would like to comment on
I'm
that.
going to go in, I'll jump right in. So I think the first thing is I'm not sure whether the funds are a direct reduction in healthcare, but we'll leave that as a fact check request. I have been involved in a series of a Victorian government initiative over the last couple of months, and it's called the Brand Challenges. So it's trying to get different groups together to look at significant health challenges in the Victorian community. They recently had a showcase. I want to reassure you that at the crux of, I think there were 8 presentations, most of them weren't necessarily suggesting a technological solution. So these were all kind of, if we could put forward something, a dream team for the MRFF from Victoria, what would it be? So it was all kind of, it was a little bit wanky. But anyway, what I want to say is that at the heart of those was not necessarily an expensive technology. It was actually a combination, but at the core was recognising that a lot of reform could be done with huge impact. So I don't think that MRFF is going to be completely wasted on pie in the sky, blue horizon sort of technology.
I'd like to add to that by saying, looking at what the MRFF want to fund, the priority areas, I was very disappointed to see that preventive strategies were a very small part of the big financial bubble. So I would like to spread the research money to really, if we invest in more interventions, including social interventions, that will actually make it's actually 1,000 times cheaper to fund research into the prevention rather than the treatment. So I utterly support more supportive and early intervention strategies. So I'll do all I can to try to campaign for that. We definitely need those. So I would agree in part with you that I think there's a lot of potentially, although all diseases are terrible, there's a lot of locking the door after the horse is bolted. We really need to divide that research funding into prevention. There's some very basic questions that can be answered by a fraction of the total of the MRFA as to why we get disease, why genetically, but more importantly, socially, environmentally.
I just wanted to add to that, Jeff's talk about epigenetics and how we're sort of interested in seeing how things will play out in terms of chronic diseases. One of the benefits of having more testing available and having more of this science developed is, of course, that we can prevent the chronic diseases if there is that significant environmental impact. So if we know from the test that something should be avoided to avoid the development of a chronic disease or to mitigate some of its effects, then that is preventive. And of course, I'm a recovering public health scientist, so I will always vote for more money for preventive medicine because, of course, it's the greatest benefit you can actually have with that amount of money. You will never match public health in terms of efficacy for any medical intervention. But again, some of this actually does fall into public health and preventive medicine as well. So there is intersection there. It doesn't have to be either or.
John?
Yeah, thank you.
John?
Thank you very much for terrific presentations, and it's actually nice to see a disciplinary mix, I guess, amongst the panel. I'm sure you could have your own debate. But look, I wanted to ask a similar question, I guess, sort of an opportunity cost type question. And Jeff started off by telling us that there's 13 million preventable deaths per annum. I presume that's not Australia, I presume that's globally. Well, I guess my question is really trying to link that sort of statistic, with some bigger picture macro questions around some of the global challenges we face. Obviously climate change and depletion of resources, growing inequality. And I think from overconsumption we're starting to see declining life expectancy in the United States. Now, if we have 13 million preventable deaths per annum, aren't we just going to see a more rapid increase in global population. And isn't that going to exacerbate some of these longer-term macro problems that we face? So I guess I'm just sort of wanting to put, a very important ethical and scientific debate into, but ask you to sort of think beyond, I guess, what is your particular interest to that broader global interest, and to think about the future of mankind.
I'd like to start by saying it's a really interesting question, a really important question, and a different way of looking at it, but an important way of looking at it. I think, yeah. So that statement that we really are aiming for 13 million extra people in the world. On one hand, we're thinking, yes, great, we've got a lot of healthy people, but then there's all the issues associated with overpopulation. But ethically speaking, it's an interesting ethical question, isn't it? Whether we could argue that we actually don't want overpopulation and we don't want to bother with prevention of those diseases. And in fact, people dying of chronic diseases is part of the normal spectrum of life. But then you speak to an individual with a chronic disease, or a parent or a grandparent, and they will utterly disagree. Rightfully so.
Well, yes, in terms of should we be saving the lives of people currently in existence, of course we're often not discussing just someone being alive or dead. We're discussing someone suffering for quite a period of time before they die. And obviously there are ethical ramifications for that in terms of how we treat the other people. But if we're concerned about the economics of the situation, it's also very expensive for people to die horribly and slowly. And so it's a horrible thing for them to experience. It's a horrible thing for their families and communities to experience some of these chronic diseases. But again, it is expensive, and it does cause a drain on the healthcare system as well. So my side of the argument is always to promote the lives that already exist and perhaps prevent making more of them, rather than not saving the ones that already exist.
Mm-hmm. Yeah, it's like a health economist's thing that they like to say is that actually smoking is good health economically, because people tend to drop dead when they're 50 of a heart attack which kills them suddenly without any kind of protracted illness at the end of the super productive part of their life. So
I've seen that argument made.
Yeah.
Isn't that Logan's Run?
And the other just thing to mention quickly is like Donna Haraway, who's like a very famous woman, science studies person, says she's been saying the last little while, make kin, not babies. So she thinks that we should have new forms of kin making, especially things like elderly people becoming siblings to each other, but not having babies. So that's interesting.
And non-human relationships.
That's right. That too. Yep. Multi-species relationships. I think Dominique, and then you.
I'm certainly not an expert in public health or population control, but my understanding is that one of the most effective ways to reduce the number of children being born is to educate families, women in particular. And once you have that socioeconomic development, you have fewer children, which is why, of course, we have concerns that certain countries, Italy, I think famously at one point, there was quite a lot of anxiety about the Italians dying out because people weren't reproducing as much as they were expected to. So I think the implication or the presumption we've had there that by trying to save lives, we might be inadvertently contributing or very significantly contributing to the problem of overpopulation, I think is somewhat misleading. I think we can help to prevent those deaths and help people to lead better lives and also manage population issues. I really would be keen to know of any evidence that would link those two really significantly. That's a non-expert opinion.
I would like to ask Professor Morgan regarding gene therapy. The person that went blind through gene therapy, was it through embryonic cells or was it adult cells?
So it didn't involve gene therapy, but it certainly involved cells.
Stem cells, sorry, if I
Cells.
may have some sort of thing, yes.
So, and what happened, they used the patient's own cells. So it was actually cells taken from via liposuction, and those cells were injected in. The cells themselves didn't cause a tumour or a growth. It was actually the procedure was applied so perhaps inexpertly that it detached the retina and caused other problems with the eye that led to blindness. So it was probably a misadventure that led to the blindness. There's other examples, of course, where cells are grown inappropriately.
Yes.
But I think it's a very good example of and just to be clear, there is no evidence that sticking fat cells in your eye will restore vision. So it was an unfounded intervention with a high risk given the way, the mechanism or the mechanical delivery of the cells.
Well, in Japan and in America, they were performing, and they are performing, adult stem cells from a person's own cornea, and this is for keratoconus. And what they do get stem cells, the person's own stem cells, so they don't even get rejected compared to embryonic stem cells. And it has been working pretty well in both Japan and America, using the person's own stem cells, and they have had some amazing results.
Yeah. So that's actually a different condition, and I think that's a great point to raise, that when we're talking about this sort of technology, how we tailor it and how we kind of deliver it for that condition can't necessarily, it shouldn't be extrapolated and say, so therefore we've got now a new treatment for all forms of blindness.
Yes.
So I think that's a great example of how you can use the limbal stem cells that surround the iris, grow them up in the laboratory from the patient, make a scaffold basically, a band-aid.
That's right.
And then you cut off the damaged part of the cornea and lay it over. So that work has got European regulatory approval, conditional approval, and it is being applied in Italy and other countries. But it's sort of only treats that particular form of blindness.
It's also been used also for the knee. I spoke to one lady who had the first stem cell, her own stem cells on the knee, where she couldn't walk, she couldn't go up the stairs, and she was the first one in Australia who had it, and it worked very well using her own stem cells.
And that's wonderful, and I'm just going to say that's a great anecdote, but we mustn't confuse an anecdote with a clinical study.
Yeah.
So that area isn't an accepted intervention yet.
I might just come back to epigenetics and just before we finish and ask, ask Megan and Evie actually, both questions extrapolating what they were saying to epigenetics. I was wondering, first Megan, so obviously stem cells have led to this whole dodgy market. Genetic testing has also got its own maybe less dodgy market because it's just testing of leisure activity potentially. But anyway, you might correct me there. But can you see epigenetics leading to a whole kind of market of therapies which might be unproven? And so I just want to ask Evie, and then I'll get you both. And then Evie, you were talking about the ethics of genetic selection, basically. Can you see epigenetics leading down that kind of same path, or is it, qualitatively different? All right.
So the first thing I'd say is that I think, yes, there will be a marketplace. How effective the marketplace is for the community, I think, will be an issue. So I suspect there'll be some kind of tablet. So in the stem cell space, we have stem cells you can rub on your face, or you can inject into you, or somebody else can inject into you. And I suspect there'll be something like that on the marketplace, a pill or something like that. And then escalating from that other more invasive procedures. I do want to just say quickly about the microbiome though, and say that I think that's kind of already there. I think there's some clinics, and I'd be interested to know what Jeff's observation's been, but I hear about clinical use of microbiome fecal transplants, but then I also hear about that being done by beauty therapists and stuff like that. So I can see the exploitation there slipping very quickly into practice.
Addressing the microbiome issue first, a good case in point is vaginal seeding, where knowing the scientific knowledge of knowing that the baby coming out the so-called natural way, it gets a different set of microbes on it than being just whipped out and taken out. It actually, the microbes on a caesarean baby are more like those from the hands of the people who delivered it rather than the mother's vagina. However, those differences disappear by about 3 years of age. But that sparked a number of people taking things into their own hands by taking an absorbent cloth and wiping it round the vagina for those deliveries that need to be caesarean, and then wiping that over the newborn. Now, I've even seen someone a scientist who got up at a conference who said he did this with his baby. The only problem is, or the main problem is, that you can be seeding the bad with the good. If the mother's got an infection, then you're putting that infection onto the baby. So yes, it's so simple, people are doing it, and the recommendation is don't do it. For epigenetics, there is a pill, there's a skin cream, there's a website that basically says we compare your epigenetics with your ideal skincare product, and they're sponsored, not surprisingly, by a skincare company. And again, to use a phrase that Megan used, this is utter bollocks. But it's not actually doing anything illegal or wrong. But if people are paying through the nose for something that's non-scientific, we would like to warn people that they're spending their money. They might as well just go to their favourite department store and buy their favourite cosmetic for a lot less.
I wanted just to say something, and maybe you probably will go ahead on this, on the qualitative difference between genetics and epigenetics. Well, I think, so let me give you a more recent example. So insurance companies are starting to use this technology of epigenetic clock to measure the real biological age of people versus their chronological age. And the argument is that you are cheating on your age because your lifestyle has been very wrong, etc. So when I will sign the contract of insurance for you, you will pay for this. So the point in epigenetics, I think, and the major difference with any form of genetic knowledge and testing and screening we have known in the 20th century is that there is a deeply moralizing implications. So it's not just revealing that you have a faulty gene, for which you can blame your mother perhaps to have delivered you as a baby, but we are screening the fact that you have been a bad citizen, fundamentally, an abnormal citizen, someone with an abnormal lifestyle. And this is, again, sorry if I return to ancient times, but historians have shown, I think, quite decisively that the reasons why humouralist medicine at some point collapsed and was replaced by modern medicine, bacteriology, etc., was exactly because this moralistic logic wasn't working anymore. So humouralism, like epigenetics, was a very moralistic idea. If you are ill, it's because you are unbalanced. And this imbalance is the result of not taking care, not having enough vigilance on yourself. Modern medicine is based on the idea that if you are ill, it's because you have a bacteria or something that not necessarily is caused by your behaviors. So I think epigenetics has a profound appeal at various levels of the sociological imagination, exactly because it has this obvious moralizing effect that, for instance, we were mentioning before about the provocation of looking at the environment rather than the genome. The problem for me is exactly what is the biopolitics of the environment going to produce? Is this true that bad environments breed bad people? I mean, this is a very, speculative argument. One can, show plenty of evidence about the opposite. So I'm not going to debate. I think that the qualitative difference is certainly sociological and anthropological, and is the fact that there is an obvious, naive, moralizing implications in epigenetic data. If you have wrong epigenetic data, it's because your lifestyle is not the one we expect to be.
Yes, so I was answering questions about epigenetic testing in ethics, right? How that's going to impact that element. Was that correct? The question you
Whether
asked.
the
It was a while ago.
issues about conditionally wanted pregnancies,
Yes,
and
excellent.
whether epigenetics applies to that, and I suppose reflecting on
Yeah.
Ritz's extremely important kind of policy-related reflection.
Yeah.
Whether, I mean, we think about genes as pathologizing the individual, but maybe epigenetics pathologizes people even more. I think that's kind of
Yeah.
proposing.
And I think, yeah, I think you're absolutely right. Everything that we've got at the moment in terms of prenatal testing absolutely could be expanded to this epigenetic testing, so looking for particular markers. And as Jeff mentioned, of course, what we want is to be able to manipulate things such that someone with Prader Willi would no longer have those symptoms. And I got to eavesdrop on a conversation between Maurizio and Patrick earlier about some very clear examples where a genetic condition can be tested in infancy, like PKU, and we can radically change the environment, diet in this case, in order to avoid symptoms. But what we're also looking at is if we are expanding our genetic testing and we're looking for epigenetic markers as well, we're going to end up in a situation similar to what we have now, which is just your choice is to terminate or to have a child with a particular condition. And most people, we know when they get prenatal tests that don't show the results that they wanted, they will often terminate those pregnancies. And again, if we're going to be looking at epigenetic markers, we will be increasing the potential for that as well. Of course, that's one concern. We don't have many cases where we would have a test like that, like in the PKU example, where we can really change that person's future by intervening in a meaningful way. There's not that many genetic tests or epigenetic tests that will be able to do that at this stage. Hopefully in the future that will be the case. It'll be more meaningful to say you've got a particular marker. At the moment, as I said, often the choice is to terminate a pregnancy, or we'll find out information like, for your particular genome or your particular markers, you should be engaging in healthy exercise, diet, etc., which, to be fair, we all know already. So it's not exactly news that we should be engaging in healthy lifestyle choices. Being told you're at a slightly increased risk of cardiovascular disease doesn't necessarily change much in that particular way. So yes, I think it will expand further. I think we'll end up with more of what Maurizio was saying, the blame for people's environment impacting their health. Yeah, there's great potential for more discrimination. But what we want is, of course, more of what Jeff was saying, the ability to meaningfully intervene, to prevent things, to manage symptoms, rather than just seeing it as something that pathologizes certain people.
Thank you, Evie. Brilliant words to end on. Thank you, everybody.